Hi students, welcome to physics class. Welcome to physics class. Today we are going to discuss a new concept, that is motion. Motion in a plane. Once again, today our new concept is motion in a plane. Now, I would like to explain point by point. Point number 1, position displacement. Position displacement position displacement velocity and acceleration. That are needed yes described the motion of an object. Motion of an object along a straight line. Along a straight line. Now, the directional aspect, the directional aspect of these quantities can be taken by positive, can be taken by plus and minus, or positive and negative signs. In one direction only, two directions are possible. In one dimension, only two directions are possible. Once again, I am repeating this content. Our concept is motion in a plane. Position, displacement, velocity and acceleration that are needed as describe the motion of an object along a straight line. The direction aspects of these quantities can be taken by positive and negative signs. In one dimension, only two directions are possible, that is positive and negative. Now, go to point number 2. To describe to describe to describe motion of to describe motion of an object to describe motion of an object in two dimension in two dimension in two dimensions. What is two dimension? Nothing but a plane. A plane. Two dimension or three dimension or three dimension. What is three dimension? Consider space. Space means x comma y comma z. Space. We need to use vectors. We need to use vectors. Once again I am repeating the point. To describe motion of an object in two dimension. Two dimension means x comma y. X comma y. Two dimensions. This is also we can call as a plane, xy plane. Or three dimensions. Three dimension means x, y, z. X, y, z. This is also we can call as a space. In the space, x, y plane, y, z plane, z, x plane. We need use vectors. This is about the second point. All these are introductions only. Just write in your notes. So we can go to numericals or content afterwards. Just this is the point number 2. Now, point number 3. Point number 3. Velocity. Now we are going to discuss point number 3. Velocity. Velocity and acceleration. Velocity and acceleration in a plane. Velocity and acceleration in a plane in the bracket two dimension. Two dimension. Two dimension defined by vector. Defined by vectors. We can discuss motion of motion of an object. Motion of an object in a plane with the help of vectors. Once again, I am repeating the point number 3, my dear students. Velocity, acceleration, velocity and acceleration in a plane. Plane means xy plane or yz plane, either only one plane only. In a plane, the plane we also called as two dimensions, defined by vectors. We can discuss motion of an object in a plane with the help of vectors. This is point number 3. Now, point number 4. Motion in a plane. Motion in a plane. Motion in a plane in the bracket. Motion with constant acceleration. Motion with constant acceleration. Projectile motion. Projectile motion. Comma circular motion. Circular motion can explain can explain by vectors. Once again, I am repeating the point. Motion in a plane. Motion in a plane. What is that one? Motion with constant acceleration, comma, projectile motion, comma, circular motion can explain by vectors. Now, point number 5. We can classify the physical quantities. We can classify the physical quantities. We can classify the physical quantities. We can classify the physical quantities as scalar, scalars or vectors. Once again, what is our 5th point? We can classify or divide the physical quantities. How many physical quantities we have? So many. I can give some example. Distance, scalar, displacement, physical quantity, it is a vector. Speed, it is also a physical quantity, that is scalar. Velocity, it is also a physical quantity, it is come under the vector. Acceleration, it is a physical quantity, it is a vector. Work, it is a physical quantity, it is a scalar, like that. Okay, that means we can classify the physical quantities as scalars or vectors. Now go to the point number 6. Scalar. Scalar, a physical quantity A physical quantity which has only magnitude which has only magnitude but no direction such a physical quantities such a physical quantities called as scalars. It is specified completely by a single number along with proper unit. Now, once again, a physical quantity which has only magnitude but no direction. Such a physical quantity is called as scalars. It is specified completely by a single number along with proper unit. Example, the distance between 2 points. Point number 1, the distance between 2 points. Point number 2, mass of an object. Mass of an object. Now, point number 3, the temperature of a body. The temperature of a body. Once again, I am explaining these three. What are the example? Distance, mass, temperature. All these are come under the category of scalar. Now, the distance between 2 points, mass of an object, the temperature of a body. These physical quantities come under the scalars. Therefore, now point number 7. Point number 7. Scalars can be added. Scalars can be added. Scalars can be added, subtracted. Scalars can be added, subtracted, multiplied. multiplied and divided just as the just as the ordinary number. Just as the ordinary number. Once again, scalar can be added, subtracted, multiplied and divided just as the ordinary number. Now, point number. Now, example. Example for this one. If the length and breadth, if the length and breadth, if the length and breadth of a rectangle are are 1.0 meters and 0.5 meters, then its perimeter is the sum of the length of the four sides. Sum of the length of the four sides. If the length and breadth of a rectangle are 1.0 meters and 0.5 meters, then its perimeter is the sum of the length and the sum of the length of the four sides. That is 1.0 plus 0.5 plus 1.0 plus 0.5, that is equal 0.33 meters. Since the length of each side each side is a scalar and the perimeter is also a scalar. Once again I am repeating this point. Since the length of the each side is a scalar and the perimeter is also a scalar, therefore what we understood, scalar can be added, subtracted and multiplied and divided. This is one of the important point. Now go for point number. Next, go for another example. Go for another example. If a uniform, if a uniform solid cube, if a uniform solid cube of aluminum of side 10 centimeters has a mass of 2.7 kg, then its volume is 10 to the power of minus 3 meter cube, and its density is 2.7 into 10 cube kg by meter cube, is a scalar. Once again, I am repeating the point. If a uniform solid cube of aluminum of side 10 centimeter has a mass of 2.7 kg, then its volume is 10 to the power of minus 3 meter cube, and its density is 2.7 into 10 cube kg per meter cube. It is a scalar. So what this point indicates? These points explain about a scalar which will be divided by a scalar gives another scalar. Okay, I hope you understood. Now go for point number 8. Now point number 8. Vector. A physical quantity which has both magnitude and direction. Such a physical quantities called as vectors. Now example displacement, velocity, point 2 velocity, point 3 acceleration, Once again I am repeating, my dear students. What is a vector? Now we are going to discuss point number 8. All these are introduction of motion in a plane only. Now point number 8. Vectors. A physical quantity which has both magnitude and direction. Such a physical quantity is called as vectors. Here example is displacement, velocity, acceleration. Now point number 9. A vector is a vector is often represented by an arrow. An arrow. Bracket, this is called this one. This is head. This is tail. Placed over a letter. Placed over a letter. Say V arrow. The magnitude of a vector is often called its absolute value. It is indicated by V bar or magnitude of V, that is called V. Once again I am repeating the point, my dear students. A vector is often represented by an arrow. This is the symbol of arrow. Placed over a letter, say V bar or V arrow. The magnitude of a vector is often called its absolute value. It is indicated by V bar or mod V, that is called V. Now, point number 10. Unit vector. Unit vector. Unit vector. A vector of unit magnitude, a vector of unit magnitude and has the same direction and has the same direction as that of the given vector. given vector, it is represented by, it is represented by it is represented by A cap, A cap, or A hat, A hat, or symbol A cap, like this. Therefore, A vector is equal to magnitude of A into A unit vector. Once again, A vector is equal to the magnitude of vector and A unit vector. This also we can write as magnitude of A into A cap. Therefore, A cap is equal to A vector whole by A, that is equal to vector whole by modulus of vector, modulus of vector. That means A cap we also write as A vector to the magnitude of vector. So these are the important points. You please keep in a bracket or keep in a box. It has no units. It has no units, no dimensions. No dimensions, but direction. But direction only. Once again, it has, that means unity vector, has no units, no dimensions, but direction only. Now go for point number 11. Point number 11. In Cartesian coordinates, in Cartesian coordinates, what are the Cartesian coordinates? I cap, comma, j cap, comma, k cap. I cap, j cap, k cap are the unit vectors along x-axis, comma, y-axis, comma, z-axis, respectively. Once again, I am repeating. In Cartesian coordinates, I cap, j cap, k cap are the unit vectors along x-axis, y-axis, z-axis respectively. Now that means take x-axis, take y-axis, take z-axis. Along x-axis, the unit vector is I cap. Along y-axis, the unit vector is j cap. Along z-axis, the unit vector is k cap. So, this diagram supports this important point. This is about the introduction of motion in a plane. These are the important points. Please go through it. Thank you very much for watching this video. Thank you.